Pendergrass is a senior attorney at the Environmental Law Institute. I'll just briefly, we're going to do two introductory shows. I'll talk a little bit about the history of production. We have 5 minutes. And turn it over to Bob, and Bob will essentially talk you through the article. The article's outside, and that was the cover story in the Environmental Forum about a month ago. And then Jay will make some comments on these environmental implications from a legal and regulatory and government side. So I'm going to start with just some basic slides about, is this a big deal? And so people think about this. So here's our printer, and the thing that was quite striking to me when I was building this is I used this. Okay, and why is this important? I'll just kind of go through this quickly. If we talk about the evolution of manufacturing, this was the basic tool. Right? So people go back to the first paradigm, it was craft. It was, people call it filing and fitting. You just file stuff and both fit together, and if it didn't fit together, we'd file some more. And that sort of evolved a little bit. So I'll just take you quickly through. The early craft system was about filing and fitting. The English got very good at that and fast at that by building jigs, so you can actually take it apart and say, I'm going to make something like this, and I'm going to file it and fit it until it looks like this. In the 19th century, there was a huge breakthrough called the American system of manufacturing. We just got very good in terms of making good machines like milling machines, and also being able to measure very well. So that gave us interchangeable parts, and that led to mass production. Early 1900s, we applied scientific management techniques to mass production. I left Frederick Taylor, so we were focusing largely on how we organize the work. We started using statistical process controls, started hooking computers up to production machinery, and then use computers in flexible manufacturing. So that's a rough sort of quick tour through the manufacturing paradigms. The important thing to think about is every time there's a paradigm shift, labor productivity went up by a factor of 3 to 4. So this is a huge, huge gain. All of a sudden, these paradigms left, so it got us to a point where we were producing a lot more things for society with about the same labor. So these are huge sort of step changes as we go across a number of centuries. So we're changing tools, we were changing process controls, and we were also changing how we organize humans and the interface of all these three things. And I think that's important to think about. It wasn't just people, it wasn't the tools, it was how we control the tools and also how we interface with human beings. And that'll have some implications for 3D printing. So this is what it was about. I mean, I've tried to reduce this into some bullets. This greater precision, higher speeds, lower costs. Right? So we had this capacity for what I call reproducible precision. And now it's moving into other areas like biology, where we can actually engineer organisms that do things that we want them to do. And we don't have to spend hundreds of millions of dollars to do that. So some of the important shifts, one was analog to digital control. I mean, people talk about digital fabrication. We've had digital fabrication for decades. I mean, as soon as we had these huge computers, the vacuum tubes, we started hooking them to machines. A lot of that happened in the military sector initially. I think the big shift that we're looking at, and these were, I would say, largely machines that took stuff away. Right? So the lathes, millers, drills. I mean, you started with some block of metal, plastic, whatever, wood, and you're taking stuff away from it. You're milling, you're drilling, you're routing. The shift we're going to talk about today is subtractive to additive, which I think is a pretty significant shift. So we're actually building things up from the bottom. It's not new. This is an early 3D printer in 1984. This is a 3D printed object that was given at MIT in 1989. And it's been sitting on my bookshelf, and it's a very interesting reminder of just how slow things are. And I've made a complete idiot out of myself for years by telling people, this three-dimensional printing revolution is right around the corner. And it wasn't, right? And I finally got an email from someone at Yale who said, I remember you saying this 12 years ago. I thought you were crazy. But it's an interesting thing. I mean, this has actually been around for quite a while. Machines were kind of ponderous, they were difficult to program, but all of a sudden, things have become fairly easy. So, but again, the thing I want to emphasize is things don't happen immediately. They might appear that they're happening immediately in terms of the way the press covers them, but there's almost always a long history there. And quite often it's quite invisible, either because it's happening at universities or it's happening in the military sector. We don't see it. So, prediction's very difficult, especially if it's about the future. We just put up a bunch of predictions about this market, and we've dealt with emerging technologies for about a decade, nanotech, synthetic bio, and whenever something comes out, you have this flood of predictions. This is a disruptive technology, it's going to change the world, the markets are going to grow 10 times faster in 2 years, and they all look pretty much the same. You sort of have this battle of the predictions going on. And here you see some of them that come out of various think tanks and reports that you have to pay a lot of money for. The one in the bottom, I think, is interesting. The third industrial revolution potential of 3D printing is overdone, given the uncertain growth potential in the consumer market, limited pragmatic applications. So there's always these kinds of projections about mass impacts, disruptive technologies. It's going to change everything. There's a bunch of people who make money by saying, no, it's not going to happen. So you have to wade through all of those. We spent a lot of time trying to do that. So how big are the markets? These are just some of the projections on global market growth for 3D printers. Could be up to 8 billion by 2020, 2022. The interesting thing to ask is, okay, is this a big deal compared to the market for global machines? So the market for global machine tools is, last year, was 94 billion. And most of those machine tools are subtractive. But this gives you some sense of, it's not insignificant what we're talking about, but it's still a fairly small piece of the machine tool market. And the other way of looking at this is not just the value of this, what's the value of what this makes, which I think is important to think about. So this just looks at the market of actual parts coming out of 3D printers. And the big ones are going to be in aerospace, medicine, electronics. That little sliver at the top, which gets all the attention, is actually consumer products, consumer printers. So you've got a lot more of these coming out. I can go to Staples now and buy one for about $1,100, and it's going to drop considerably. But in terms of actual value added to the economy, where you may see a lot of changes actually in other areas that are, I would say, semi-invisible right now. We've been doing a documentary film on additive manufacturing, and we're going around and talking to people that are making turbine blades and prosthetic devices, and I think these are the things that are really going to be game changers. So I think one of the things that people forget about, and to me the thing that is really revolutionary potentially about, is sort of our ability to do rapid prototyping. So inside the innovation cycle, called the design, build, test system. So I design something, I build it, I test it. And sometimes it fails and I go back. I worked for a number of years as an industrial designer, and this was unlike. I was able to sketch ideas incredibly fast, and then I spent weeks in a model shop trying to build things. And some people innovate through three-dimensional objects. Edwin Land developed a Polaroid camera, never used sketches. Steve Jobs was a touchy-feely guy. He went in and talked to his ID folks all the time. He wanted to see things. And so I think the innovation impacts might be even more subtle, in the sense that we actually can innovate in 3 dimensions and test things out. And some people do that very, very well. They're not good at sketching. They're going from sketches to 3-dimensional objects. So I think the idea that this is going to change the innovation cycle is quite profound. And this is where you're beginning to see this. Even kids are being given the potential of prototyping their next generation tools, and earphones, and bicycle parts. So some people estimated that this is about 80 or 90% of the use right now is just rapid prototyping. So what other things are going on? Well, medical applications are a prime example, simply because we have lots of digital images. We're always slicing and dicing our bodies up with CAT scans and MRIs. So this is actually a woman at the bottom whose jaw was completely shattered in an accident. And we went in and basically did a visual image of the side of the remained. The body's perfectly symmetrical, but we're able to do a 3-dimensional print of the jaw replacement. We did some filming. What was that? We did some filming at Children's Hospital of pediatric surgeons that actually were getting ready to go and operate on a newborn's heart, and they printed the heart out. So they were actually able to begin to look at what the heart would look like when they open a child up. So we'll see prosthetic devices. We'll see people developing different. This is a heart valve. It's been scanned. People are building rotor blades for jet planes. Hard to imagine. So you can 3D print titanium. And this way it's done is just with an electron beam welder. Same principle, comes in at 10,000 degrees Fahrenheit, hits titanium and just deposits pieces. So you're building up. You need to think about this as more. It's not just plastic stuff. You begin to be able to actually print ceramics and titanium objects. It's quite a game changer. This is actually done in a vacuum. People are playing around with car bodies, fuselages from planes, furniture. This is a very large 3D printer at the top, so also stop thinking about these things as little tabletop devices. We're just printing out very small things. Somebody mentioned dresses, art, fashion. Artists always are early adapters of this. These are people that are doing jewelry. So I think the interesting thing is the penetration is in lots of sectors. So we're getting a lot of innovation driven by 3D printers in all kinds of sectors. The chefs love this. We love this thing up with Nutella. Anything that has the right viscosity, you can print. So you can print fairly complicated edibles with these 3D printers. So don't be surprised if you go into a restaurant and somebody says, do you want your face printed out? It's possible to do it. I actually have a small app in my iPhone that I just take a bunch of photos of my face or any object and we'll stitch them together into a three-dimensional model form. So the server could come up and actually do the face, print it out and send them. Who knows? The other thing to think about is it's not just about additive replacing subtract. This is a device that I don't know how they got this through the X-ray machine downstairs, but somebody at MIT brought it to me, and it basically is a pop-up fabrication system, but it's a computer controlled, just like this. You can move an X, Y, and Z axis, but the heads change. So you can put a milling head on it and take things away, or you can put a 3D printing head on it and build stuff up. So I think the important thing is not to think about this as just, okay, it's going to be, we're going to have substitution. This never works that way. So the synergies between the two might be quite profound. And people are already thinking about machines that do both of those. Biotech. This is an interesting idea, still in the idea. We do a lot of work on synthetic bio, but this is something in Imperial College where essentially it's waste to print. So you don't put plastic in, you put junk or refuse in. The refuse goes into a bioreactor. They've engineered some organisms, so what comes out is essentially recyclable plastic that is then printed. So the input is no longer just plastic, it's actually junk and waste. So we're going through two processes, the first one being biological, the second one being an additive manufacturing process. So, it's a quick introduction. So we've been thinking and working in this area for a number of years, and we sort of said, okay, what are the environmental energy impacts of this? And I think the thing that got us involved was that there was just a lot of claims rolling around. People would say, well, it's subtractive is going to produce less waste. Most of these on the surface seem logical. Not taking something and basically taking things away from it, building it up. Subtractive could reduce, additive manufacturing could reduce carbon footprint. I can actually print where I need something, or manufacture where I need something. Big implications for military logistics, that sort of thing. So if I'm a Maytag repair washer guy, I don't need a huge inventory, I just need the digital pattern for the part. I can actually print it out. If somebody asks for, got a washing machine that's 10 years old, why should I keep that in stock? So there are some interesting things. And there's also this issue of do the same thing we do with paper, just start printing a lot of this stuff. So I think the thing that was interesting, there's certainly a lot of claims out there. We spent months asking, is there any research to back this up? I mean, Bob was working for months. We had a mechanical engineering student from the University of Virginia here, just scouring, peer-reviewed literature, grade literature, anything. Said, okay, has anybody really looked at this? Has anyone sort of asked questions beyond, wow, this intuitively seems or anecdotally seems like it would work this way? And so I think one of the interesting things we're trying to do is to sort of just stimulate more research, so we can ask and answer these questions now early before we have lots of these out there. So I will turn it over to Bob. I will take you kind of through the thought process in the article, and kind of what we dug up after probably about 5 months of research.